Hello, this is Grazie, your friendly neighborhood flame artist. And if you're anything like me, you have used and loved many times the very vast collection of Matchbox shaders that Flame has to offer. As you all know, a lot of them have been created by the community and they have come very handy to a lot of us. And thank you Autodesk for sponsoring this video. And if you clicked on this video, it's probably because you're curious about how to create your very own Matchbox shader. And if I was right, then I'm very happy to say that you are in the right place. Think of this as a very basic introduction into Matchbox shaders, what they are, how they work, and ultimately how you can create your own. Let's start from the beginning. What is a Matchbox shader? Matchbox is a tool in Flame that allows you to load a shader that's either provided with Flame or created by a third party. But what is a shader exactly? Shaders are programs that transform inputs into outputs. Think of it as a set of instructions that tells the computer how to transform a piece of information. Our information in this case being pixels. I think it's important to mention that although there are different types of shaders, like vertex shaders or face shaders, Flame only allows us to load or build pixel shaders, which are also known as fragment shaders, using Matchbox. So we are going to only focus on this kind. And what a pixel shader is going to do is that it's going to affect each pixel of any given image individually and convert it into an output. I think it's also relevant to mention that the way that the script of the shader is going to refer to each of the pixels is through its coordinate location. So as you can see on the screen, I try to represent how a computer might see the location of the pixels. So you have a location in X and a location in Y, and those two components are going to create a vector. The one that I'm displaying on screen right now is in the location 6, 1, 6 in X, and 1 in Y. And you'll also probably going to notice that at the beginning of my X and Y coordinate, I start with 0, meaning that the very first pixel in my X location and Y location is going to be my pixel 0. And this is something that's very common in computer language when we start the array of numbers with 0 instead of 1. There are also different concepts that we need to get comfortable with if we want to start building our own Matchbox shaders. And some of those are the different data types and variable types that we can declare in our shader script. And I'll just quickly go through the most common variable types that you're going to find in Matchbox scripts. So starting with Boolean values, which mean that there are a true or false statement. Then we have integer values, and those are whole numbers. So those are numbers that are going to look like 1, 2, 3, or also negative 1, negative 2, etc. And then we also have float point values, which are numbers with a fractional component. So those numbers are going to look like 1.0, 1.5, 1.8, etc. And then we also have vectors of 2, 3, and 4 components of floating point vectors. And we declare them as vec2, vec3, or vec4, depending on how many components they have. We also have a sampler 2D, which is a reference to a texture 2D, which has an attached texture object to it. We also have a void, which is used to identify functions that do not return a value or parameter list to a function that are empty. Understanding vectors is key in the creation of Matchbox shaders. So I want to take a moment to explain vectors a little bit further. The definition of a vector is a variable type with several components. And we already talked about how we can store in a vec2 the coordinate location of the pixels in a canvas. But it's also very important to note that the RGB information of every pixel is stored in a vector of 3 components. Those 3 components being the red, the green, and the blue channel. And as you can visually see on the screen, you'll see that a true red is going to be represented by 1 in the red channel, and then the other channels being zeroed out. So it's going to be a vector of 1, 0, 0. And then a true green is going to be represented with 1 in the green channel, and that's why it looks like 0, 1, 0. And then blue is going to be represented as 0, 0, 1. And we can actually see this concept applied into Flame whenever we bring up a color sampler. And you're going to see as you move it around that it's going to give you 3 values for red, green, and blue. Black being 1, 1, 1, and then white 0, 0, 0. And all the combinations of red, green, and blue in between are going to basically build every single color. Now, let's talk a little bit about what files make up a Matchbox shader. Matchbox shaders are made up of 3 files. The first one being the GLSL file. That file contains the code of the shader that processes the pixels, meaning that here is where the magic happens. It contains all the instructions of what the shader is going to do with the information received from the pixels to output it somewhere. It is written in a C-like language, which is called GLSL, and GLSL stands for Open Graphics Library Shading Language. Next, we have the XML file. And the XML file is a Flame-specific script because it contains the code that dictates how the user interface controls in the Matchbox shaders are going to look like. XML stands for Accessible Markup Language, and it's going to look a lot like the language used to build websites. Lastly, we have a PNG file, which is the file that contains the proxy icon that is shown when we browse for the Matchbox on the server. And these 3 files that make up a Matchbox shaders all need to be named the same way. The only difference is going to be their extension, the .glsl, .xml, and the PNG. Let's do a quick search of those 3 files on some of the Matchbox shaders that Flame has available for us. If you didn't know, there's a really nice library that the Autodesk developers provided to us called Examples that are meant to be used by those people that want to get into building Matchbox shaders. And there you have access to see a variety of scripts. And as you can see here, I found all the GLSL, XML, and PNG of one of the Matchbox shaders. And here's another one for blending. We have GLSL, XML, and PNG. I also highly encourage anyone that is interested in getting into this to open some of the scripts just to see how they were built, and you can also play with them to change them and adjust them a little bit. Now that we know that these 3 files make up the Matchbox shader, the GLSL being the shader script and the XML being the UI script, you might want to know how they communicate with each other. And they do so through uniform variables. Within a shader, uniform variables are pieces of data that are read-only, and their values can only be changed from outside of the shader, meaning the XML file. They are declared in the GLSL file, but can also be referenced in the XML file, allowing these 2 scripts to cross-links. The only thing that we need to make sure is that those uniform variables remain the same name. Also, the uniform variables can store things like size and dimension of your image, the current frame, and the parameters of the effect. And there's also a utility that Flame has available to us called the Shader Builder. And when we run it on the terminal, after we build a GLSL script, then it first of all let us know if our script compiles correctly or if there's any error in it. And then it also would create a XML file for us for the UI that is very basic that we can start with. The Shader Builder utility also contains a lot of useful information for those who are interested in creating their own Matchbox shaders. They have information such as how the XML script is built and some uniform values that are specific for Autodesk and Flame. So all those things are very useful, and we're going to play with that a little bit when we write a piece of code and test it out on our Flame. The first thing that I would like us to do before we build our first script is to look at a pre-existing script and see how it was built. You'll find that GLSL scripts follow certain structure. You'll see that at the top, the uniform values have been declared. GLSL is a strongly typed programming language, which means that you need to specify what type of value you are storing in each variable. So that's why you're going to see that after every uniform, you're going to see either a float or a sampler 2D, which means that we're specifying the variable type each time that we declare one. And right after the uniform variable declaration, you're going to find the main function opening, saying void main void. Right after that, you're going to see a piece of code that I notice appears over and over in GLSL scripts. And what that math is doing is basically converting our canvas and our resolution into a normalized resolution. So basically what that's doing is having a canvas that instead of going from, let's say, 0 to 1920 and 1080 for height, it goes to 1 and 1. And the way to do so is dividing the coordinates of each pixel by the width and the height of the canvas. I understand that piece of math may seem a little bit confusing, but the more that you use it, you get used to it and it's going to make a bit more sense. Lastly, you're going to read a variable that reads GL color at the end of the code. And you're typically going to find it there because that is where the final pixel color is going to be assigned to. So basically that's our result. And in that result operation, you're going to see a texture 2D, which has a sampler 2D and the ST that we declared for the normalized coordinates. So think of that as the texture of the result, which has a sampler of a 2D texture assigned to it, that then the ST specifies where in the canvas each of the pixels are going to be assigned to. And then here we can see an XML structure, which is going to contain the UI, the user interface code, and this is kind of how it's going to look like and how it's going to be built. Now let's move to the fun part. Together we're going to create a Matchbox shader that does some simple color operation. So we all know very well the color correct. And what I'm going to try to do is simulate what happens in the offset control, which is basically a lift. What that's doing is adding a number to the RGB channels all at once to lift the color or just make it darker. As I mentioned before, there is a shader builder utility that is available to us that can help us have access to some helpful documentation before building our our GLSL file. And as you can see, I already created a file that's named lift.glsl. And on the left, you're gonna see me typing the location of the shader. And then with H, we have access to really nice documentation that tells us a lot about the uniform types and some uniforms that exist only in Autodesk for Flame. And yeah, you can see it's a very long document that can help us create our first line of script. But because I have this already pre-built in here, I'm going to use that a little bit as a shot sheet. This is what we use to analyze how a Matchbox shader is typically built. So the first thing that you're going to see me doing is declaring my first uniform variables. And I'm going to start with the Autodesk result width and height, because I know, as we mentioned before, that I'm going to want to normalize my coordinates of the canvas of my input. So just searching and scrolling through the documentation that the shader builder has available for us, so that you can see that there you can also find all that the Autodesk specific variables that you have access to, and it's right there. As you can see the Autodesk width and height, and if you want more information, you can definitely look at this document. So I already declared the width, so I'm going to go ahead and declare a uniform flow height as well. And then, because I also need access to the input texture, you're going to see me declaring a uniform variable that's a sampler 2D, and I'll name that input 1. Now the last uniform value that I want to create is the one that I'm going to have control over. As you can see, those last 3 are very dependent on the input that I'm getting before my shader does its magic, but I want one that's going to be able to change the color value of my input, and I'm going to call that one lift, because that's the one that's going to control the lift. The next thing that I'm going to do is that I'm going to open up the main function, the same as we have in the presentation. So I'm just going to type void main void, and I need to open and close the fancy parentheses for the body of my script. And you'll also notice that at the end of every script line, I add a semicolon. That's very important. And the next thing that I'm gonna look to do in my script is doing that normalizing of my coordinates. So here you'll just see me declaring that vec2 variable that's going to store the normalized information of the coordinates of my pixels. And I'm gonna script it a little different that I have in my in the back in my sheet. So basically I'll bring the frag chord as a vec2 with x and y, and divided by a vec2 that contains the Autodesk width and height. And again, that division is going to normalize the coordinates. And because of how the vectors behave when I do any sort of functions between them, a vec2 and another vec2, what's going to happen is that the GL frag chord x is going to be divided by the first component of my vec2 in the division, which is the width, and the y is going to be divided by the height. And then lastly, you'll see me adding some information into the GL frag color, which is going to have the final pixel information. So I'm going to use a texture 2D in there where I'm going to put the texture being the input. That's my uniform value. And my normalized coordinates that I kind of like declared on top. And to that, because that within itself it would just be would give me my input colors, and to that I want to add a lift. And once I save that on the server, I can use my very handy shader builder on the terminal and see if my GLSL file compiles nicely or if there's an error in it. So the first thing that we need to do that is find where my shader is located on the server, and we need to try to find it on our terminal. So here it is. I saved it on a grassy shader folder. So here you're just gonna see me opening that same location in the terminal. And once I make it to the right location, I can run my shader builder, which I have access to by typing the location of where it is, which is right there. And then I hit M and I type the name of the script that I created. And when that run, it showed me an error, as you can see in there, and it's specifying in what line it's finding the error. So it seems that I have some syntax error. So I'm gonna see what's happening over there. Line 11, sorry. And it seems that I have a naming error there. So it should be input 1, not just input. So I'm gonna fix that and save my script again, and then run the shader builder with it again. And this is great news. It ran really nicely. So as you can see, it output for me a very basic XML script for it. So I'm gonna copy it and create an XML file. And by copy pasting it in here and naming it accordingly, remember that I have to name it the exact same name of my GLSL script, which is lift, and make sure that it is an XML file. And now this is the moment of truth where I test my shader on Flame. So we'll see. I'm gonna bring up a Matchbox shader. And remember, I put it under Grassy Shaders, and there it is. There is my lift and the controls with a slider, and it seems like it's doing exactly what I wanted to do, which is a huge success. Yay! And also so that you guys can see the connection between the XML file, which controls the UI, and here I'm just gonna do like a quick update on it and change the column 1 display on it so that it says control. And once I save that, technically it should change the column 1 text in it to controls. So we're gonna test that right now. And yeah, it seems like it worked, which is amazing. Thank you so much for watching, and I hope you find this video helpful.